Friction is a force that affects everything that moves. It is what opposes motion. It can occur when two surfaces are very close together, as there will be an attraction between the molecules of the two surfaces. It can be affected by the roughness of surfaces. The rougher the surface, the more friction there tends to be. This is why it is much easier for someone to slide on ice than on grass, as ice has a much smoother surface. And finally, friction occurs because of the plowing effect. This is what happens when the top layer of a soft surface sinks into its lower surface. A great example of this is when you are walking on sand. Each step you take, you sink a little bit, making it more difficult to walk. Streamlining is how we can reduce friction, in particular air resistance, a type of friction that is caused by air pushing against an object. Racing cyclists crouch down low on their bikes and wear smooth, rounded helmets to help airflow over them more easily. This reduces air resistance and therefore lessens the effects of friction. Lubrication is also used to help reduce the effects of friction. It is added between surfaces to fill in gaps, making it easier for the two objects to pass one another. A moment is a turning effect of a force. Forces can make objects turn if there is a pivot. A pivot is a point around which something can rotate or turn. The best visual for this is a playground seesaw. The pivot is the middle part. It is level when no one is on it, but once someone is on one side, it tends to tip. To figure out the moment, you need the force being exerted and the distance from the pivot. On the left of this diagram, we have a weight of 10 newtons. It is 2 meters from the pivot. To get the moment, it would be that 10 newtons times 2 meters, giving us a moment of 20 newton meters. The right has a mass of 20 newtons, and it is 1 meter from the pivot, making its moment 20 newtons times 1 meter, giving us again 20 newton meters. From this, we can see that the two moments are equal, making it balanced. The left-hand side would act in an anti-clockwise direction, while the right would act in a clockwise direction. This means that if we were to remove the weight on the right, the seesaw would tip to the left. If we were to remove the weight on the left, our seesaw would tip to the right. There are two types of waves, longitudinal and transverse waves. Longitudinal waves have vibrations that are parallel to the direction the wave is traveling, such as a sound wave or ultrasound wave. Transverse waves have vibrations that are at right angles to the direction of wave travel, such as ripples on the surface of water and light waves. Sound is an example of a longitudinal wave. It will not travel if it has nothing to pass through, such as air particles. So if we were to put sound in a vacuum, so say a glass jar that we've removed all the air from, the sound could not move and we would hear nothing. The more dense the substance that the sound is passing through is, the quicker the sound will travel. Sounds can be changed by changing the properties of the waves. There are a few properties of waves. The first is the amplitude. It is the maximum height of the wave from its resting position. The greater the amplitude, the louder the sound will be. The frequency is the number of waves per second. The higher the frequency, the closer the waves are together, and the higher the pitch. The wavelength is the distance between the crests, or peaks, of the two waves next to one another. We can see these properties through the use of an oscilloscope, which gives us graphs similar to the ones in this slide. A few other keywords to remember is that a vibration is a back and forth motion that repeats itself. Volume is how loud or quiet a sound is. This is measured in decibels. Listening with a volume too loud can be damaging to the human's ears. Lastly, an echo is what happens when sound waves reflect off of an object and return to the listener, such as the walls of a cave. If you were to yell into a cave, usually you'll hear whatever you yelled come back at you. Next up, we're looking at light waves. Now, reflection is what happens when a light ray meets a different medium. Some of the rays are absorbed into the mirror, while the rest bounce off of it. The law of reflection states that the angle of incidence is the same as the angle of reflection. This means that the angle the light comes from to the normal is the same as the angle the light reflects off of the mirror, again, to the normal. The normal is a perpendicular line to the mirror surface, as seen in our diagram. Refraction is what happens when a light ray travels from one material into another material. It will change directions. If the light ray is going from air into water or glass, it will bend towards the normal line. The angle of incidence will then be bigger than the angle of refraction. The emergent ray, so what comes out on the opposite end of the material, is then the opposite to what we just said. The angle of incidence, where the ray comes from, will then be smaller than the angle of refraction, as it will bend away from the normal. Although it may not look like it, white light is made up of all the colors of the rainbow. We see this when we pass light through a prism. It splits into 7 colors: red, orange, yellow, green, blue, indigo, and violet. These colors that we can see are known as the visible light spectrum. Although we can see many different colors, our eyes can only see 3: red, green, and blue. Yes, these are different than the primary colors you may have heard of in art. All colors are therefore a mixture of these 3 colors. Again, that's red, green, and blue. For example, if we see something that is yellow, it is actually made up from red and green light. In our eyes, we have 3 color receptors called cones. Each cone can take in one of the 3 main colors: red, green, and blue. If we see a green object, it is because of the cones responsible for being receptive to the color green. When we look at yellow, we use the cones for the colors red and green. We see objects as specific colors due to the way that light is reflected. When the light hits an object, it will reflect specific colors back to the person. For example, if an object appears red, it is because only red is being reflected by the object. The rest of the colors are being absorbed. White is an example of all of the colors being reflected back at us, whereas black is what we see when every single color is absorbed by the material. The solar system is made up of planets tilted on axes, orbiting the sun with moons orbiting those planets. Our solar system is known as the Milky Way galaxy due to its milky-looking color. This is due to all of the stars or light-emitting bodies within our solar system. The Milky Way is only one of billions of possible galaxies within the universe. Because space is so large, it is unrealistic of us to use kilometers or miles when talking about distance. So instead, we turn to the measurement of light years. This is how far light can travel within 1 year. The value we use is 9,460,700,000,000 meters, or 9.4607 times 10 to the 12 kilometers. The reason we use light years is because one of the closest stars to us is still about 4.3 light years away. Earth is the third planet from the Sun. It takes approximately 24 hours for the Earth to rotate on its axis. This gives us days. When the part of the Earth that you are on is facing the Sun, it is day, and when it is facing away, it is night. A year is how long it takes for the Earth to rotate around the Sun. This is approximately 365 days. Seasons occur because of the rotation of the Earth. In the summer, the northern hemisphere, where we are, is tilted towards the Sun, making the days warmer and longer. In the winter, the Sun is spread out over a larger area due to its placement in relation to where we are. We are now tilting away from the Sun. Because this energy is spread out over a larger area, but still emitting the same amount of energy as usual, it makes the days feel colder. There are two types of eclipse, lunar and solar. The lunar eclipse occurs when the Earth blocks the Sun from the Moon. This means the order is Sun, Earth, Moon, or SEM. The solar eclipse occurs when the Moon blocks the Sun from the Earth. This means the order is Sun, Moon, Earth, or SME. Depending on where you are at the time of an eclipse, it may appear differently to you.